I'll get us started. Welcome everybody. Welcome back to the Path Seminar Series. I'm Scott Mora. Welcome. And it's my distinct pleasure to invite and welcome Professor Eric Cheng, who comes to us from a couple hours away at UC Merced, where Professor Cheng was telling me he started as a new professor at the beginning of September. So he's 2 months into the UC system. Welcome. It's a pleasure to have you here. And actually, Professor Cheng, he was also telling me that prior he was at Hong Kong Polytechnic University for about 20 years, where he's a faculty member there. And so North America checked, we have Asia checked, but before that, he was in the UK, in Europe, where, you went and got your graduate degrees at the University of Bath.
That's right.
Not far from actually Wales. Or is that in Wales?
That's right. They are quite close, about 2 hours from there.
2 hours away. Okay. And then after your PhD, you were telling me that you worked for Lucas Aerospace.
Yeah.
Yeah, working in aerospace defense applications. So, a wealth of experience, but fresh to the UC system, and has a topic that's keenly interesting and kind of different than anything interesting to me and different than what I've seen before. So anyways, when I first heard about you and the work you're doing, I thought, oh, it'd be great to have you come and share your work. So welcome. We're delighted to have you in the UC system.
Thank you so much, Cheng. So today I share with you some of the development they've been doing for last many years, especially in electric vehicle. Something we'd like to share with you will be on this particular topic called ammonia power electric vehicle system. So first of all, then I'd like to just introduce myself so that you know deeply more about what I'm doing. So I've been working on power electronics for many years. So that's how I was trained. And my research area mainly on all the power conversion, basic power utilization, and high frequency and motor and system. So you see all these things we really good fit into the electric vehicle. So for the last 20 years, I've been working on electric vehicle. So especially working on the mobility system, energy storage system, how to provide the new energy for electric vehicle. So that's how we develop this kind of new area of technologies. So first of all, today my content of my talk will be mainly about electric vehicle, mainly focus on ammonia powered electric vehicle. So I can go through the energy storage and also hydrogen fuel cell, why we have been using hydrogen fuel cell. And the next little bit here, you can see we are trying to talk about the ammonia powered electric vehicle solution. So that's something quite interesting. I'd like to show you what we're doing and how we use ammonia as a power conversion, how we can convert ammonia into electrical power for the electric vehicle, and then how we design an EV on that. And then I conclude my talk. So firstly, try to examine about electric vehicle charge. We've been using EV for many years now. So I think many of us have an EV anyway. So why we still continue to use EV, and what is the hurdle for EV? Anything we need to be careful, what is charge? So you can see that for last many years, global warming is a major issue we've been working on. And then, of course, carbon neutrality 2050 Paris Agreement, we know that we need to go for 2050 zero carbon emission. So in order to do that, then that means we should be able to gradually replace all the fossil fuel by electric vehicle or zero emission method. So one of the ways will be how to use electric vehicle on this manner. Electric vehicles, theoretically, we have zero emission for the everywhere located us. So in this case, if we're able to use electric vehicle, we should be able to eliminate most of the fossil fuel. At the moment, still many vehicles are based on fossil fuel. So in this case, that will be a big problem. Not only car, but for vehicle, we also look into the ship, boat, or the rickshaw and aircraft system. They are also a high generation of the CO2. So that's why we need to really look for this area. At the moment, we're talking about the battery. So battery is one of the main things for electric vehicle. But however, do you think battery will be a good solution? The thing is, batteries do have some emission. Later on, we'll discuss about why battery could be still a solution, could be a method. We still need to think about that. So that's why for last many years, been thinking about hydrogen. Hydrogen will be one of the thing we can able to replace, probably can replace the battery. And then, but hydrogen do another issue. Later on, we'll talk about why hydrogen is still a problem. So now we're going to introduce to you ammonia power system, how we use them for the electric vehicle. So for the battery, we know that battery has been used for many years. I think we continue to use battery for the next many years. But however, we know that battery still suffer from a number of problems, including recycling problem. How do we recycle the battery? We know we put a battery in the bin, then it may go to recycle system. But I don't think that recycle are doing it properly, especially for electric vehicle. You can see that in next many years, we are going to have a lot of the electric vehicle battery retired. So how are we going to deal with this kind of the battery? So you can see that our EV at the moment, we want an EV can go for more than 1,000 km. Most of the EV today only about 500 km at most. But to go from more than 1,000 is what we like to see. And then another issue will be, can we 100% recycle the battery? The battery are being manufactured in some special manner. To 100% recycle them will be really, really a big problem. So that's why at the moment we still suffer from how we recycle battery. Do you think a battery will be a long-term solution for all the electric mobility system? And then, but the thing is, battery is not only used for EV, but it also being used for another renewable energy system, including solar power, wind power, anything. If we want to store the renewable energy, we need to use battery. So that is to say, we do have a problem. So we are now going to use a lot of lithium for the battery. Lithium is really good chemical to use for battery, including lithium oxide, lithium sulfur, or lithium iron phosphate. They are all good battery systems. But the thing is, if we could keep using the lithium, would that be a problem eventually? At the moment, we got roughly about a few percent of EV electric. But in the future, if we got 100%, or we need to build enough energy storage for the whole power system, we'll end up with a big problem. We'll run out of the lithium. So that's something we have been thinking of. We are not quite sure how true it is. At the moment, the present development for electric vehicle mainly we go for a long duration of the traveling. That's something we like to see. So we know that presently the battery may not be able to give us high or long distance or really rapid charge within a few minutes. So that's why people think about, shall we use hydrogen? So hydrogen economy has been discussed for last many years, maybe 10, 20, maybe 50 years. So it seems that hydrogen will be one way you can go forward. And at the moment, there's many other different type of the fuel cell system. Not only hydrogen fuel cell, we also have other many different type of fuel cell, including metal air fuel cell or many other type of fuel cell. You see, hydrogen one of the major things. Why is that? Because hydrogen, firstly, hydrogen is zero emission, hydrogen is available everywhere, and also hydrogen is relatively high efficiency and also low operation temperature. So that's a really good nice. We can use hydrogen vehicle, like hydrogen fuel cell or all the system in a lot of the mobility application. But we can see that there's also many other energy storage available, not only hydrogen fuel cell, including the supercapacitor, we can use them, and also flow battery. So red dot battery also something quite good we can examine, and also the liquid metal battery, also something we should explore. At the moment, we don't see too many applications on this field area of the energy storage. Mainly, we tend to focus to use hydrogen to replace the battery. So you can see that the current situation is that we do have a lot of the EV in the market. Many countries, for example, including the UK or other locations like Hong Kong, have been talking about gradually to replace the vehicle by electric. So we can also see that at the moment, the registration, you can see that we have about 1.4 billion vehicles, but only 1.2 are passenger car. So you see passenger car are much easier to convert into electric. But overall, there's only 2.7% for the whole world are electric. So it's far way to go to reach 100%. And however, you can see that for the last few years, there's a good trend. because every 4 vehicle being shown, one of them will be electric. So now you're getting more and more people switch to electric vehicle. But in the US, we see that we got 280 million vehicles, only 1.2 are electric. So still a little bit lagging behind, so we need to catch up. But we can understand that because in US, the travel distance used to quite long, to use electric for charge a vehicle is quite inconvenient. If you want to go to the airport, go to other city, you need to travel for maybe 200 miles, and then 400 miles is quite difficult for EV to fulfill. So that means at the moment, still we have to think about better energy storage to replace the battery vehicle. But however, if we want to fulfill the carbon neutrality by 2050, there's a global requirement for the country, sign the agreement in Paris. We like to do that. So to do this one, we only have 20-something years to go. So we need to convert all the fossil fuel into electric or zero emission manner. So that requires a target we need to fulfill. So to do this one, probably first of all, we need to think about battery vehicle or maybe hydrogen vehicle. That's something we need to look into. So that's why, but however, we know that if we convert everything into battery vehicle, we have big problem about electricity. You see, today we only have 1.2 electric vehicle in the US, but if change them in 100%, then how much electricity we need? Then my estimation will be 10 times of the existing power source. So that means we need to build 10 times the power station to see it's impossible. So that's to say, we need to think about another solution. We can't only rely on battery. Because we rely on battery, we need electricity to charge them. Where can we build so many power stations? At the moment, the power station, 1/4 of power station are coal-fired. That will be emission. And then another 1/3 probably will be natural gas, another 1/3 probably will be nuclear. So if we try to convert everything to zero emission power generation, I think still a long way to go. So that's why we see that to have 100% battery vehicle probably may not be a good solution. So that's why people talk about hydrogen vehicle. So that's why I come into for the last 10 years, we've been talking about hydrogen economy, trying to use hydrogen to replace the battery or other means of the new energy. So now then go back to our electric vehicle. So you can see that basically the electric vehicle consists of all these basic or major components, including the battery is mainly about the key high power component, like the battery is the key things, and then we have the inverter to control the motor, and then we have the battery voltage to reduce the other voltage. For example, like 12 volt to other electronic for the vehicle, and then for the left-hand side, we input the electricity, charge the battery. Then sometimes if you think about fuel cell, we use some fuel. The fuel can be any fuel related. Fuel cell can be hydrogen fuel, or maybe for my research with ammonia fuel. And then we do need to have a battery management system to control battery, to make the battery become nice and safe and easy to handle and long lifetime. So for other electronic, we are trying to replace all the hydraulic and mechanical system by all electric, including we are using an engine braking system and also suspension. Everything will convert all the mechanical part into electric. So you can see that in the future, if you go for electric vehicle, a lot of the component, hydraulic, mechanical component will disappear. Will mainly about electric. So I can see that I think now we can train more engineers in electrical engineer to work on electric vehicle. You can see the other 20 years, if 100% of vehicle are electric, then probably all the mechanical engineer will retire because we only use electrical engineer. So that's my, probably may not be true. But anyway, so you can see that the key thing is the battery. That's what my main message I want to deliver. How do we tackle the battery? We're not quite sure. We like to have a wonderful, high-performance battery, long duration. We don't need to recycle or 100% recycle or can last forever. But probably that is not the case. So for energy storage, we know that basically we can classify the energy storage into this number of area, like electrochemical, electrostatic, mechanical, and chemical. So for the left-hand side, you can see that We got all the familiar battery, like the lithium-ion battery, maybe fuel cell, also the chemical type of the system, and then conventional battery, like the lead-acid one or lead-cat battery, and then the red dot battery also under development. But as you said, that is something don't rely on chemical reaction, like superconductor or supercapacitor is something we have been using for some energy storage, but still not quite yet in the electric vehicle. And then for mechanical one, we did use some of them for energy storage, but haven't quite extensively to use for vehicle. Chemical fuel, of course, like hydrogen fuel, ammonia fuel, or gasoline, they're all chemical. So basically, they are all that thing we like to look into. But it seems that most reasonable to go for carbon neutrality with those green things like ammonia, hydrogen, and fuel cell. We tend to gradually to remove the gasoline and lithium-ion battery because we don't like that. We think they do have a big problem. So for energy storage, you can see that which one is the best. They all have different characteristics, including either we got really high power density that we can generate a lot of power, or they can store a lot of the energy density. So supercapacitor are able to provide really high current rapidly, but you can only store very little bit of energy, not much. And fuel cell is the one we like to do that because basically it's based on chemical fuel, can store a lot of energy, but the power level very too high. And lithium battery was something in the middle between that. So that's why for future vehicle design, we may still need to use some lithium-ion battery, maybe some supercapacitor, maybe some fuel cell, a combination of them, depending on your design and your configuration. But mainly, if you like to continue to use the fuel cell, then you're able to travel for long distance. But for short duration of traveling or acceleration or overtaking, you may need to use the supercapacitor or lithium-ion battery to provide you the rapid energy. But one thing you can see that why we don't like the lithium battery will be mainly about the supply and the cost. You see, lithium battery mainly depend on two chemicals, lithium and cobalt. The price of them are fluctuating so much for the last few years. This diagram to show you for the last 5 years. So you can see that for 2019, the price around this much, and then near the COVID-19, the price go up so rapidly, become a few times, not a few percent, a few times higher than the price. And then the gradually coming down again. And then we're expecting the price will also go up in the next few years. The price for cobalt will be doing something similar, also fluctuating so much. You see, if a battery manufacturer, the battery will be so much fluctuation within a few years. Probably not only a few, within 1 year, you can double a few times the price. Then you'll end up with a problem. You're not quite sure how to work with the battery or battery vehicle. And other issues, including the battery at the moment, we have difficulty for the recycling. Most of battery vehicles, they only can run for 500 km. That's one of the law, you can see that. And so that's why we really need to look for other type of the fuel, not only the battery, other type of energy storage to store the energy in the vehicle, so that you're able to easier for recycling, the price are more stable, or the chemical widely available. You see, lithium or cobalt, relatively rare earth material, not exactly rare earth, but quite expensive. At the moment, most of the supply are come from Africa. We still look for a new mine, but still a long way to go. But still, the lithium will be a lot of the environmental group talking about it. And when they do the mining, it's not quite environmental friendly. Lithium not only to use on car, but also in ship or other energy storage. Even though the mobile phone, solar power, we are also using lithium battery. So that's another issue we are thinking about. You can see that in the next 10 years, if the vehicle from US raised from 1.2% to 50%, then how many batteries will be needed? And then also for power generation. Today we tend to use zero emission. So that means solar power is something we like to do. But we know that we are now building a lot of the energy storage system along the power distribution of a huge amount of battery storage to support the power distribution. So that is huge amount of the energy storage. So you can see that in next few more years, the demand for battery is getting higher and higher. So there's demand for lithium and cobalt getting higher and higher. So probably if our vehicle basically rely on lithium may not be a good future. So let's go through the history for electric vehicle or for vehicles. On the left hand side, you can see that you got conventional petrol vehicle, the gasoline vehicle. So gasoline vehicle, of course, have been used for many years, really stable, really reliable, but still have an emission. We gradually try to retire them. And of course, they're really mature technology. We are really safe. All the vehicles are really safe. And then we move on to a hybrid vehicle, like the Nissan or other, and Toyota do have a number of the hybrid vehicles. They have been using really well. And so a combination between the lithium battery and the petrol car, usually the mileage can be double or 3 times. So that's why we have been quite nice to see that. And then we move on to lithium battery, then with 100% zero emission. The thing is, the very big thing about hybrid still on transition because still have the emission. So that means eventually we want to eliminate all that emission, become purely 100% lithium-ion battery vehicle, become zero emission. That's what we like to see that. But because of the issue for all the battery, we need to move on fuel cell hydrogen vehicle. So because hydrogen must be zero emission, really easy to recycle the hydrogen. Hydrogen is one of the major elements in our planet Earth. So that probably fuel cell will be one of the best choice. But now I want to tell you, we are now looking at the ammonia power vehicle, which is even better solution than hydrogen. So in this first slide, we're going to show you what we are doing now. So now then, let's look at firstly the carbon footprint for the lithium battery. For different type of the vehicle power, we've got 100 kilowatt of vehicle. So that's a larger battery size. For medium size vehicle, 60 kilowatt hour and 40 kilowatt hour of the battery system. So you can see that when we manufacture the battery, we do have the carbon emission. So that's to say the carbon emission is not few. So we do need to have drive a vehicle for longer duration in order to offset all this carbon emission. So you can see that if usually we need to drive a vehicle at least for 2.7 years in order to compensate for all the carbon emission, then we do the manufacturing for the battery. That's not very nice to have. Even though a small vehicle still need 1.1 year to do that. If our energy come from 100% renewable, say solar, then we can reduce them to 2 years. And then reduce to 0.8 years. So that is to say, your driving electric vehicle is not environmental friendly. First 2 years, you still, the battery will mean there's another carbon emission. So you need to drive your vehicle at least more than 2 years in order to compensate all the carbon emission. So that's something we need to tell you. Battery vehicle is not 100% zero emission. When you manufacture a battery, it causes another carbon emission. So let's look at the hydrogen. So now that we know battery may not be too good. So how about the hydrogen? Will hydrogen become something nice to have? But firstly, hydrogen has been talked about for last maybe 20 or 30 years. You all think about how to use the hydrogen vehicle better. So hydrogen vehicle is one of the key technology we've been using for the last many years. So firstly, hydrogen fuel cell must be zero emission. The emission only is water. And also hydrogen is one of the major elements in our planet. So that's why we don't have any issue of the hydrogen mining. We don't need to do that. And the recycling, of course, will not be any issue. So that's why many people like to use hydrogen. So now then you see that interesting will be hydrogen fuel cell have been invented for a long time, 1839. So nearly 200 years. So, but however, we still didn't see too much major development. At least in the last 50 years, we did not see the fuel cell vehicle being used extensively. So instead, the battery being used more often. But we can also see that there's a lot of major enterprise manufacturing the fuel cell, like all these big companies. they're worldwide company, you can really easy to get the hydrogen fuel cell. So that's to say, hydrogen fuel cell must be a clear advantage, but still we can see that hydrogen vehicle still not quite extensively being used. So let's examine why it is. So you see hydrogen, although is nice to have, but still quite expensive. Basically, hydrogen, we can classify them into a number of different types. I think you all know about it, the green hydrogen, blue, gray, and brown hydrogen. So we like green hydrogen because it means will be 100% zero emission. The energy we use to generate hydrogen from electrolysis are mainly new energy, solar energy, or wind power, zero emission energy. And the next thing, blue hydrogen really crack all the hydrocarbon fuel, like the methane, crack them, but the CO2 in general or carbon general will capture them, do not allow it to release to the atmosphere. So that means new zero emission. And next great hydrogen will allow it to be the CO2 emitted to the atmosphere. So that means if you're using great hydrogen, it's just from our concept, it's not carbon emission. So zero. And another brown hydrogen is using really lousy coal, so we do have a lot of emission, not only CO2, but have many other emissions. So then eventually we do like to have a green hydrogen. But obviously you can see that for green hydrogen, it must be really expensive because you have to use the electrolysis and also renewable energy to do that. Renewable energy power usually more expensive than fossil fuel or coal-fired generation. But blue hydrogen is something we like to have, but still expensive. So today, most hydrogen we bought from the market are green hydrogen. So even though the one you're using for hydrogen vehicle in the pumping station, you probably are using green hydrogen. Yeah. So that's something we don't like to hear. So that's to say, if you're using hydrogen vehicle, it looks like you are still in emission, but in fact, there's a huge of the emission behind you. So
Wait, have you heard of pink hydrogen?
Oh, that's many names. I'm recall, maybe you can tell me more about the pink hydrogen.
I guess they made it up as maybe it's a variation of green hydrogen where they use nuclear power
Oh, nuclear
to do electrolysis.
Wonderful.
Why pink?
Well, hydrogen has no color, so this is all complete nonsense to begin with. I don't just.
I thought it would be yellow for like yellow uranium or something.
I think nuclear should be one of the first solution. I think because still need carbon emission, then probably they also rely on nuclear.
Yes.
Another issue we can see that for hydrogen, and then some of the blue thing is some of the information is not important. People have been doing some calculation. They see that according to the analysis, so usually consider 1 gallon of the diesel an equivalent 1 kilogram of hydrogen. So that's these two energy really not about the same. But anyway, however, for 1 bar of hydrogen is too low energy. Because for this and one normal 1 bar of atmosphere pressure, the amount of the storage for hydrogen is too few. So that's why usually we pressurize it to 700 bar in order to get sufficient energy storage. So if you do that, then probably the storage tank must be really powerful, really thick to do that. So for instance, you can see that for a storage tank about 100 kilograms thick metal, we can only store for 5 kilograms of hydrogen. So for safety, hydrogen today is really safe. But because we want to store them, then we need really firm solid of the storage tank. So in order to store them for 700 bar. At the moment, all the international standard for hydrogen storage will be either 700 or 350. So that's why we have the issue. We do get really good material. Secondly, there will be some leakage because when we store them 700 bar, there will be some leakage. So leakage usually about 1 month storage to leak about 10%. So that's something we don't like to hear then. Another thing is how to use hydrogen in the city. Yes, in many countries we do have fire regulation. We don't allow the hydrogen station inside the city center. Today, because gas station in the center, we can fill in our car quite convenient, but hydrogen may not be the case. we may not able to fill our hydrogen vehicle everywhere. So especially in some country, we don't allow the hydrogen vehicle to drive through the tunnel or bridges. The thing is also fire regulation. In case anything happens, the whole tunnel may disappear. So that's something we still are something we don't quite sure about that. So mostly today, all the filling stations are outskirts. So that's why many stations. So there's some example in Japan. You can see that the fuel is still quite high. I just do some analysis. You can see that for green hydrogen, then the price may be 0.48 per kilowatt hour. If we try to compare them with the diesel, only 0.11 per kilowatt hour of the energy. So that's why you can see that hydrogen is still expensive. The one we get hydrogen from the hydrogen station are mostly green hydrogen. If you want to get the green hydrogen, usually with 4 times more expensive. So that's why I can see that in the future, if we will go for hydrogen vehicle, we do end up with to pay more, or the government need to subsidize much more of that. So now then, let's look at the ammonia. Do you think ammonia could be a better solution? Let's see that. So ammonia in free we call it NH3. So for 1 mole, we got 3 hydrogen as compared to hydrogen gas, we got 2 hydrogen H2. So for gas law, for fixed volume, then per unit volume, then ammonia actually has more hydrogen than hydrogen gas. So that's why for the last many years, when we want to transport or store the hydrogen for long duration, then we tend to use ammonia. We firstly convert the hydrogen into ammonia for storage. Why is that? Because ammonia to store them is much easier and cheaper. The storage pressure for ammonia only 8 bar. Close to 8 bar, then ammonia can be liquefied. So that's why really convenient for us to store them. That is really similar to LPG gas. So for example, like LPG gas, you can see that the container is very thin because these two are very much similar operation pressure. So any station, if can use LPG gas, then you can also replace them with ammonia. So that means in the future, if you want to change a gas station into ammonia, would be much convenient. But you cannot change any gas station into a hydrogen station, impossible, because they're completely different operation. So for the project, we tend to look into ammonia to examine about the performance, efficiency, how to use them for electric vehicle. So the project we are doing will be trying to apply them to use that technology into a minibus. So that's the first. After 3 months, then we first develop a golf car, a smaller vehicle to prove the concept. So that's the first electric vehicle we build using ammonia. So we had to use the power electronic solution to do all the motor driver system. We developed the ammonia cracking system to crack the ammonia in hydrogen and then to drive the electric vehicle. So basically, the vehicle is the same as hydrogen vehicle, but the front end we put in ammonia cracking system. So that is to say, we crack the ammonia on the vehicle rather than to store the hydrogen. Because we don't like to store the hydrogen, it's too dangerous to store any hydrogen in the vehicle. If stores too much, we have fire regulation. The vehicle can pass through any tunnel or high surge. So that's why we don't store the hydrogen, we only store the ammonia. Ammonia only offers 8 bar. So for example, like this little tank here, for this golf car, this tank is able to travel for 1,000 kilometers. So because the energy content for ammonia will be much better compared to battery. So the concept will be quite simple and quite straightforward. The ammonia, we crack them into hydrogen gas, and then we pass through the fuel cell, normal hydrogen fuel cell. The hydrogen fuel cell we generate electricity and go for the so-called MPPT, maximum power point tracking system, to track the maximum max operating point, and then we store the electricity in here as a battery temporary store there, and then you can use them to drive the motor. So the whole system we need to control the temperature, the flow rate, the power, and also speed. So we do management to control the whole system.
Can you say something more about the chemical reaction to crack ammonia? So you got NH3 as a reactant, one of the reactants, and you have H2 as one of the products. I imagine atmospheric air is one of the other reactants, so there must be some nitrogen oxide product as well when you crack, no?
In next few slide, I'm going to show you what happened. We don't
Okay.
have NOx there because we don't remove any oxygen in that cracking. We only crack ammonia into N and H.
Okay,
So we are not burning the ammonia into power. Because other technology, they may burn the ammonia into electrical power to generate the energy, but we don't do that. We just crack it. We use another technology to crack the ammonia into nitrogen and hydrogen. Does not involve any oxygen. So that means the key thing will be we don't involve any NOx, no NOx at all.
I see, but nitrogen is
Nitrogen
in
is not a greenhouse gas, it's just a leader. Hydrogen into the atmosphere. And then the hydrogen
Yeah.
will therefore go to our system.
I suppose you could inject it into soil, it's a nutrient.
Oh, yeah,
right?
yeah.
Yeah, but anyways,
Which do you inject into the soil?
Huh?
What are you injecting into the soil?
N2,
It needs to be made into accessible to the soil. You need to turn, but that's why ammonia, that's why I'm really curious, because when I hear of ammonia, my biggest question is ammonia right now, ammonia production is a very, going to like your colors with the hydrogen, ammonia is a very, very carbon intensive process to make. When we, so normally, and correct me if I'm wrong here, but ammonia is current, it's one of the most, if not the most commonly produced chemicals in the world, and it's predominantly used for
synthetic fertilizer.
for fertilizer, and that's why they have to take the nitrogen and use whatever the Haber process. Sorry, my chemistry background's a while behind me.
That's right, yeah. Then,
Haber-Bosch, yeah.
sure, thank you. Yeah, we can also use the Haber process to develop the ammonia from N and H. That's another way we can generate ammonia. So that means there's many methods we can store the energy. So what we mentioned just now, we use Haber-Bosch process to store the energy using solar power, and then use the Haber-Bosch process to convert N and H into ammonia. And then that's how we store the energy. So that is to say, store the energy in form of ammonia is much better than hydrogen. The thing hydrogen is too dangerous. So that means the key advantage we do that will be 100% zero emission. You don't need to worry too much about the pressure. 700 bar or 350 bar is too high pressure to operate, although it's still safe, but too expensive to do that. And then we don't get handle all this high pressure. And we can show you some example about that. For example, our storage tank for 1.4 meter, 23 centimeter, this kind of conventional storage tank, we can store 22 kilograms of the liquid ammonia. The energy can provide to us will be 55 kilo-hour. So that's only initial development. We are confident this number can be doubled, maybe even further. So this amount of energy, how much can do? Can able to travel 110 kilometers for our bus at 160 km per hour. So we in SM fully confirmed that is working. So that's to say we do have a lot of potential how to use ammonia.
Eric, I missed it. How do you produce ammonia zero emissions?
So we got many different resources how to produce ammonia. Next few slides we're going to discuss more.
Okay.
So besides this gentleman talk about using Haber-Bosch process, combine N and H, we got other resources. So if, for example, like in all these locations, we do have a really good supply of ammonia. So because ammonia is a fertilizer, we can use landfill or other method to generate ammonia gas. And the generation, they do produce ammonia or maybe methane gas and many other gas. But however, ammonia can be widely available in this area because they have been using landfill and fertilization mechanism to do the generation. So like this company in South China or Malaysia, Brunei, Indonesia, and Singapore, we do a lot of them. So that is very low cost, rather than use Haber-Bosch process to generate ammonia. And also around the world, there's a lot of location, you can see here, many locations, they do have really good production or storage for ammonia. So the red color, the amount of gigagram, you can see that there's a major area here. Even though in the United States, we do have a very good production of ammonia. So that's to say, we should able to have a lot of ammonia available. Of course, you can see that if in the future, all the electric vehicle, all the electric ship or aircraft are using ammonia, we don't have sufficient ammonia. We do need to use upper cross to convert hydrogen and hydrogen into ammonia. At the moment, if you're using that method, you should able to have a really good resources for ammonia to supply to all the electric vehicle. So the concept will be quite straightforward, very simple. So we got the ammonia here. We have a cracking technique to crack them into hydrogen and nitrogen. The nitrogen, we just release them to the atmosphere because our atmosphere has 78% of nitrogen anyway. So we don't bother about it. The hydrogen will go to our fuel cell to generate electricity. So that's now our next step up or first step up for smaller system. So the configuration, you can see that right in here, we got the ammonia go for flow control, examine about the load management system, and then we go through the purifier. We still need to remove a little bit of the ammonia. That's only 0.1%, but still need to remove them and then go to our fuel cell. For the whole system for electric vehicle, we got a motor, a super capacitor for energy storage. We got also the battery system connect with them. So we can also generate the electricity stored in supercapacitor or stored in the battery so that we can able to have a high power. Because when the motor try to maybe to speed up or braking, then we get energy and store into the battery. The power generation energy cannot store in the fuel cell, only store in the battery. So we do need to put some battery there for the vehicle. So for conversion, that's our testing characteristic. So our key technology will be our catalyst. We have examined if a new catalyst able to have really nice high conversion rate. So we use RU methane as a combination of nickel oxide. So we have 1%, 0.5, 2%. So the conversion rate can able to achieve close to 99.9%, when we have a 650 degrees C. And then you can see that for different kind of combination, we also include the aluminum oxide or iron oxide, and then we all examine them at different kind of conversion rate. So since that the combination with nickel oxide with the RU will be the one of the best combination. And then we also try to examine the flow rate together with the conversion performance. So even though we have solution for slow flow rate about 6 liters per minute, we're able to achieve nearly 100%. And other case, then we also examine different flow rate for different kind of the large scale system. We are able to achieve close to 100%. So most of case, we are able to achieve about 99.9% of the conversion. So that is to say, most of the ammonia can convert the hydrogen nearly 100%. So it's quite nice to have.
So this means you need some heater on the
Yeah.
cracker,
Really,
which will be some sort of auxiliary load.
that's right, yeah. Then usually you ask how much auxiliary load, the auxiliary load works about 5%.
Okay.
Yeah, so still reasonable. So another test we've been looking into will be kind of the different flow rate and different temperature examination to see which was better. So our research continue. We try to see, are we able to search another catalyst, able to reduce the temperature. So in this case, we can reduce the energy consumption. But although temperature is very high, but our cracker decided able to convert all the heat inside rather than to dissipate them outside. So the design for this catalyst could be one of our technology as well. For the whole system, you can see that we use a modular approach to do the job. So for example, like we have Our gas tank, we got a number of tanks for the storage. And then we do have the cracker in here. Then we have the absorber here to absorb any remaining NH3. And then after this, then we go for our fuel cell. Our fuel cell also using parallel approach, a number of fuel cell operating parallel. So if we need high power, we can turn on more fuel cell. The good thing to do this thing will be because parallel operation, we can able to easier to manipulate about the power to match with the motor requirement. Because sometimes the motor requirement we need to have high power when go up the hill or full load or overtaking, then we need to change the power. So that's how our system look like. You can see that it consists of our fuel cell, ammonia cracking system, and also the filter, the steel absorber system, and also the cracking system. So all this will be located in our electric vehicle. So we also develop our own regulator to regulate how the gas being flow through them. So our tank will be 22 kilograms of NH3. So we use 5 of this tank to design our electric vehicle. We are able to go for about 500 kilometers of the travel. So here will be another test. We try to test them about the conversion. So for this NH3, then the outlet will have a really feel about the NH3 level. So everything will be being filtered. And then we try to absorb them. So the conversion will be 99.9999. So that means 100%, close to 100%, we're able to eliminate all the remaining ammonia. So this is our power testing. We are examining a different flow rate for existing system, how much power you're going to achieve. So we normally we can turn on around 24 kilowatt system. The electric motor for vehicle will be 100 kW of power, but we don't need to always 100 kW because for the cruising, the motor power only about 20 kilowatt. So that is to say, we usually using 20 something kilowatt power for the power conversion. In case we need high power, we can turn on for high power flow rate, but efficiency will be lower. So depend on our design, but usually try to optimize that at the maximum power point tracking, about 90, more than 96 of the conversion rate. So finally, you can see this our bus, our minibus, about 7 meter long. So that's arrangement for our internal component. So our seat will be in the front, most of the power component at the back. So the thing is, at the moment, there's no standard component available in the market. So we all make all the components, including the cracker, the filter, and absorber, everything will be made by inside our lab. So that's all the system design. You can see here. The fuel cell, as I said, we use a number of them in parallel. The thing is, we are not able to buy a 100 kilowatt of fuel cell, too expensive for our project. So we use a number of smaller power in parallel. In this case, if we need more power, we turn on 1, 2, and 3, 4, and so on. And the ammonia cracking system will be another independent unit. We can able to fit in the front end of vehicle. So that to say, if you do have a fuel cell vehicle, hydrogen fuel cell vehicle, I can supply to you the front end conversion unit, then your vehicle can straight away become an ammonia vehicle. So that's how our bus being used. So that's how the internal look like. Still, the component still a little bit bulky. So that's the bus we have been test drive on the road.
This is in Hong Kong.
Hong Kong, yeah.
You know, famously, there's a fuel cell trucking company called Nikola.
Oh,
And they did a demonstration of their hydrogen fuel cell truck. But they did a demonstration where they had it going downhill. And it didn't actually work. They just let it roll downhill.
I see.
So anyways, I'm thinking about that because
So
there's
something more enforced that our vehicle must be working in front of them, so no alternative. So to conclude what we have done, so so as I said, EV is all electric now, so all the moving parts are 100% pure electric. So we need to think about how the future solution, what kind of energy storage we needed, either hydrogen or ammonia or battery. Probably battery may not be 100% good solution. We need to look for other type like hydrogen and ammonia. Hydrogen we have been talking about for a long time, but we like to look into ammonia. So we now we discuss about the issue for the battery. So now the ammonia will be a good alternative to the hydrogen, mainly about the safer and lower cost. But the thing is, we don't have any supply chain at the moment. We still need to develop that supply chain, and we already eliminated the high pressure car problem. So we think ammonia will make it easier to be realized in the next few years. So the key technology we have developed will be our cracking system. We're using this 1% RU and nickel oxide, which is able to provide 99.99% of conversion. So that's one of the key technology we've been developed. We also developed the minibus and also light vehicle and also ammonia energy management system. So this vehicle is the world first vehicle, first one in the world developed using ammonia power vehicle. So updated in 2021. It's interesting when we did that vehicle, nobody in the class has done that using ammonia. They have been using hydrogen or other gases, but it seems nobody has done it using ammonia. So that means for the future development, I think multiple energy storage is something we need to look into. So we like to continue to work on ammonia power, not only for vehicle, but can also to be used for power source. Any power source can be the coal-fire into ammonia power source. And then many countries have been working on ammonia, so-called the hydrogen economy. But I think ammonia for the another economy probably can replace the hydrogen. So finally, you can see our design for the vehicle and how it look like. So we run out of time now. So that probably you can see that our vehicle 100 kilowatt bus, which is the first one in the world to develop, we use ammonia to replace all the hydrogen. Then you can see that the energy content for ammonia system at the moment will be 12 times as compared to battery. But I guess our research go on, we can increase this ratio to more than 20. Theoretically, it can go up to 40. At the moment, we only have 12. So, just lastly, some advertising. We've been developed the first commercial electric vehicle. We also developed the first charging network in Hong Kong. We also developed the first militant motor system, in-wheel motor in the world. We also developed the first all-electric active suspension and integration using supercapacitor. Now we developed the first ammonia vehicle. So that's our contribution. So thank you.
We're a couple of minutes over, but this was so interesting and unique and different. You have to go, but otherwise we could probably take one or two questions.
Yes,
Thank
please.
you. I enjoyed your presentation. I do agree that we need to look at other additional resources besides just battery. One question I have though is ammonia, I know, is like a toxic gas. So like if there was a crash, I'm curious, 'cause I'm not as familiar with this area, so like how would we mitigate that if there was a crash in this vehicle and say the tank were to leak?
Yeah, that's a really good question. Many people ask me this, and ammonia is toxic, but the toxic compared to many other toxic gas, for example, like CO, carbon monoxide, much minor. So this gas also is toxic, but however, if you compare with the other factor, including the exposure factor and flammable factor, this one is much lower than all the other gas field, including hydrogen, methane, or all the other carbon hydrogen fuel. So depending on how you think about that. The thing is, this one, you can smell easily. So that means the sensor will be much cheaper. You see hydrogen fuel, the sensor is really expensive, about 10 times and 20 times more expensive. And also if you cannot sense it by your own nose, right? So that's to say any leakage of hydrogen will end up with a disaster. Hydrogen can easily trap in any of the corner.
Yeah.
But ammonia, we won't. It's really easy. You can know that there was some leakage. So depending on how you think about that, many fuel are poisonous. So of course, ammonia also poisonous. So, but however, the advantage compared to other fuel is much, much better.
One more.
Yes, please.
You mentioned that like the ammonia system is safer in comparison to the hydrogen fuel cells. So I was just curious what tests you did to get to that conclusion, whether you did like off-nominal safety tests or what led to you making that.
We did not do any tests. We just studied the comparison in terms of the research and survey and the paper and data analysis. Key thing you can see there just now, the hydrogen need to operate high pressure. So 700 bar is 700 compared to our atmosphere pressure. You can imagine that if any explosion, that would be really run up with a disaster. You can see that if today one vehicle in a tunnel, or even the explosion probably may be able to good. But however, if all the vehicles become hydrogen, I can't imagine if any explosion, what would happen next. But ammonia is much mild energy storage. So even though explosion factor only 25% as compared to hydrogen. And the good thing is much easier for you to detect. So that's why for all the case small wheel, that will much easier to manipulate. I tell you, ammonia, what kind of gas is it? Just those cleaning in your toilet. So that kind of the poisonous level. And so that means you can smell it quite easily. But instead, if you're using hydrogen, you operate 700 bar. Any leakage will be a big problem, any explosion, not only high pressure explosion, but also the flammable will be much higher than many other gases. So that's my conclusion. So I did not do any tests, but for data model, we believe that ammonia will be much safer as compared to hydrogen.
All right, thanks for putting it together. All right, thanks everyone.